Good day everyone, we are Group Cybergenesis, and for today's presentation, we will discuss Arduino Project 7 Temperature Alarm. Our group consists of 3 members, Nanjay Nash Tiglao, who is our leader, myself, Marcia Marpuntillo, and John Michael Pajeda. We work together in completing this activity. This project is presented to our professor, Dr. Earl Marquez Albina, in partial fulfillment of our subject, Application Development and Emerging Technologies. In this lesson, we focused on Arduino Project 7, Temperature Alarm. The project improves our previous alarm circuit by adding a temperature sensor. The system works by detecting when the temperature goes beyond a certain threshold. Once that happens, the buzzer is activated and produces a warning sound. This is our first project when a sensor controls an actuator, giving us a hands-on example of how Arduino can be used for automation, safety, and monitoring purposes. The components we used for this activity are the following. First, Arduino Uno board serves as the microcontroller. Second, breadboard used to connect and arrange the components. Third, jumper wires to link the circuit parts together. Fourth, buzzer acts as the alarm output. And lastly, temperature sensor detects changes in temperature. With these parts combined, we are able to build a working temperature alarm system.
Today, I'll be explaining our Arduino project, a temperature alarm system that uses a buzzer to alert when the temperature goes above a certain limit. Alright, let's start with the first line, float symbol. This creates a variable called symbol that will store the sign value for each angle. With a float type because sign values are decimal numbers between -1 and 1. Next, we have a int tone val. This variable will store the frequency for the buzzer. It's an integer because frequency is measured in whole numbers, in hertz. Then, we have unsigned long temp timer. This variable will store the time in milliseconds so we can control when to display the temperature reading. Now we move to the setup function. Void setup. This part runs only once when the Arduino starts. Inside setup, we have pin mode 8 output. This tells the Arduino that pin 8 will be used as an output pin. That's where our buzzer is connected. Next is serial.begin with a value of 9600. This starts the serial communication at a speed of 9600 bits per second. So we can send temperature readings to the serial monitor. And then we close the setup with closing curly bracket. Next is the loop function, void loop. This is the part of the code that runs over and over again. Inside the loop, we first declare two variables, int val and double data. valve will store the raw reading from the temperature sensor, and data will store the converted temperature value. Then we have val equals analog read. This reads the voltage from analog pin A0, where our temperature sensor is connected. Next is data equals double, val multiplied by 5 over 10.24. This converts the voltage reading into a temperature value in Celsius. Now we have an if statement. If data is greater than 31, this checks if the temperature is greater than 31 degrees Celsius. If it is, the buzzer will sound an alarm. Inside this if statement, we have a for loop for int x is equals 0 and x is less than 180. This loop goes from 0 to 179, representing angles in degrees. Then we calculate the sine value. Sin val equals sin x multiplies by 3.1412 divided by 180. We convert the angle to radians and get its sine value. Next, tone val equals 200 plus int sin val times 1000. We scale the sine value and add 2000 so the buzzer frequency changes smoothly. Then we use tone 8 tone val. This places the calculated frequency on the buzzer connected to pin 8. Finally, delay, the value of 2. Pauses for 2 milliseconds before moving to the next frequency, making the sound smooth. If the temperature is not above 31 degrees Celsius, the else statement runs no tone, the value of 8. This stops the buzzer from making any sound. Lastly, we have another if statement. If millis minus temp timer is greater than 500, this checks if 500 milliseconds have passed since the last temperature reading was displayed. If yes, we updated temp timer to the current time using temp timer equals millis. Then we print the temperature to the serial monitor using serial.print and serial.println. And that's the end of our loop function. So in summary, this project constantly reads the temperature, and if it goes above 31 degrees Celsius, the buzzer sounds an alarm. It also displays the temperature on the serial monitor every half second. That's how our Arduino temperature alarm works.
So as you can see, our temperature right now is 30.27 and 30.76 degrees Celsius. Now I changed the source code for a bit so that if our data detects that the temperature is 31 degrees, it will turn on the alarm. So now we are at 30 degrees. This is room temperature. If we now heat up, since our fan is turned on, if we heat up the room for a bit and then we wait for it to be temperature of 31 degrees. Alright, look at this. The temperature is now rising up, and now the buzzer is turning on. And that's it.